for Pilot AI. 3, 2, go.
Hi, I'm Ankit from Pilot AI Labs, and we enable real-time computer vision using deep learning on embedded devices. Let's get straight to a demo. Here's an example of one of the things our computer vision SDK can do. Here, we're detecting and tracking all the people in this frame. And I want you to focus in particular on the woman on the bottom left with the bright green box. She's going to go out of the frame, and in a couple seconds, she'll come back into the frame, and our algorithm will have no problem picking her back up. Now, this is something that traditional computer vision methods might have some trouble with, and I highlight it because it shows the power of the technique that we're using, which is deep learning. If you've been following deep learning and seen the incredible advances it's had in academia, it might not be too surprising that this kind of technology is now possible. However, what should be surprising, and what differentiates us from other companies that use deep learning, such as Google and Facebook, is that while those companies require big GPU clusters in the cloud to do all their compute, all of our algorithms run in real time on single CPU cores of commodity embeddable hardware like this board. Now, that gives us a big advantage in terms of speed, scalability, and breadth of application, because we don't need to ship large video streams to the cloud and do our compute there and then get the response, which is very costly. In terms of applications, we really do believe that anywhere that there's a camera, there's an application for our technology. But today I want to talk about a couple applications that we're particularly enamored with. And the first one is drones. And specifically the drone follow me task. So this is the setup of our drone. It's a standard 3DR iris. We've strapped on a compute board to the bottom and a standard Logitech webcam. All the compute is being done on this board. So let's look at a demo. This is using the same technology that I showed earlier in the presentation. And you can see that the drone is following this bicyclist quite well, quite smoothly. It's keeping him in the frame. And unlike other implementations, he's not wearing a GPS tracker at all. This is pure computer vision. And that allows us to follow people who are not necessarily synced to the drone before the flight, and we can also switch between people mid-flight. One of the big upsides to using deep learning is that it's very simple to change the object that we're tracking. So here you can see we can easily follow a car, and when you're using deep learning, it doesn't really matter car, person, dog, pipeline. As long as you can collect the data set of it, we can train our algorithms to track it and follow it. So that's the drone application. What other applications are we looking at? Well, the next application I want to talk about has to do with these guys. These cameras are everywhere, and we believe we can provide a lot of value by dropping our software onto the existing hardware that these cameras use. So say you're using these cameras for security. We can track people across multiple cameras in real time as they move around an area and detect suspicious behavior. Or if you're using these cameras in your retail store, using the same tracking algorithm combined with some demographics classification, we can provide Google Analytics style information to brick and mortar stores. Sticking with the camera angle, consider these more IoT or smart home cameras. With these cameras, again using tracking, we can track people around the house and control things like the thermostat based on who's in what room. Or using facial recognition, we can provide parents with notifications when their kids enter or exit the house. Finally, consider a more connected smart home. These cameras can be watching you and recognizing certain gestures you make, allowing you to control other connected devices using simply your hands. For all these applications, it's very important for the compute to be done locally on the camera itself, because it allows you to build truly distributed smart camera systems where all the compute is done locally on the camera and only the result of the compute is sent to some central server. So those are a few of the applications that we're looking at. We're really excited to see what other applications there are for our technology. A bit about the company: we've got a great founding team comprised of Stanford PhDs in high-performance computing and simulation and Stanford deep learning researchers. We're actively seeking new partners and funding. So if anything has sounded interesting to you, please see me after. Or you can contact us at www.pilot.ai. Thank you.
OK, well done. Feedback for Pilot AI.
Cool stuff. How many drones would it take to do surveillance on 1,000 miles of border? You know, this crazy guy that wants to build a wall? Seems like drones would be a better choice.
Also, can the Mexican people of Mexico pay for it or no? Would they be willing to? Because I think it's a discount. I think we'd be giving them a discount against the wall.
I guarantee they will.
OK, well, we have the guarantee. I never said that.
Seriously, how many would it take?
Yeah, that's a good question. That's a function of a couple of things. One is the battery life of the drone, which is getting longer and longer as technology moves forward. So I believe that Phantom 4 now has about 28 minutes of battery life. The other is the speed of the drone and kind of the length that you want it to patrol. And those are some questions that probably need to be answered like with the people who are doing the border security to see, how long, like what the radius should be and stuff like that. But
I know
probably over 1,000.
It's a tough question,
Yeah.
but spend some time figuring it out, because I'd really like to know how many drones it would take to surveil 1,000.
Okay, I'll get back to you.
Thanks.
Yeah, don't just stick to DJIs. I mean, it's probably going to be a larger drone with
Yeah.
a better camera.
Probably.
and
A military drone, maybe. There are many of
longer
those.
airtime, but you need to be able to have people resolution.
Yeah. Yeah.
I mean, the other interesting thing about this idea, putting aside the joke about the Trump wall, is for security, you could have the drone up on a high pedestal or a camera looking out, and it could be stationary, just like a stationary security camera, but it would only take off if there was the presence of a person. So it wouldn't be used for generalized security, it would be used for pursuit. And I bet you it would be a deterrent if, I'm going to climb the fence at the factory and all of a sudden a camera is 10 feet above me. That's a pretty scary proposition,
And
I
it
think.
could follow people as they go. The other option is that with our technology, with multiple cameras, we can actually track across multiple cameras as well. So if we have like a lane of cameras, we can track people as they move across the areas.
So you could have 10 cameras that are stationary and only deploy the drone when you see movement and send it to that right spot.
Correct.
Oh, that's kind of interesting too. And then would you be able to stitch the video together and put it on Twitter for us?
Yeah. Well, soon.
Good. More feedback.
In the retail setting, how do you guys deal with privacy concerns?
That's a good question, and that's one of the reasons that it's important to be doing the compute locally on the cameras. With other solutions that might do all the compute in the cloud, you have to ship all the video streams to, for example, the AI company's servers to do the compute. When the compute is done locally and only the response of the compute is sent back, that response is anonymized, right? So none of the actual privacy concerns in terms of tracking actual people ever get sent to the central server.
Okay, any more feedback? All right, let's hear it for Pilot AI. Well done.